بسم الله الرحمن الرحيم. أعزائي طلبة وطلبات شهادة الثانوية العامة قسم رياضات لغات، أهلا بكم. النهاردة إن شاء الله هناخد مراجعة على السنتر أوف جرافيتي أو مركز الجاذبية الأرضية. Welcome my dear student in our math program for secondary 3. Today we are taking revision about the center of gravity. Definition. The center of gravity of a raised body is unique point in the space except the center of the earth. The line of action of its weight pass through it. The center of gravity. What is the meaning of the center of gravity of a raised body? Is unique point in the space except the center of the earth. The line of action of its weight pass through it. And it fixed whatever the position of the body change with respect to the surface of the earth. The center of gravity, my dear student, of any raised body denoted by capital letter G. Remarks. Number 1, the line of action of weight of raised body pass through its center of gravity and the center of the earth. The line of action of the weight of raised body pass through the center of gravity and the center of the earth. What you mean? There is line between the center of gravity of any raised body and center of the earth. The center of gravity, number 2, of a raised body is a fixed point with respect to the body, but it is not necessary that it is at one of its particles. The position vector of the center of gravity of any raised body with respect to the origin point. My dear student, let W1, W2, Wn be weight of particles from a raised body. We have a raised body. Raised body consists of small particles forming from a raised body. Its weight W1, W2, W3 to Wn. N1 R2 to Rn position vectors of these particles with respect to the origin point. Then the position vector Rg to the center of gravity of raised body about the origin is determined by this relation. Look at, my dear student, Rg equals W1 R1 vector plus W2 R2 vector plus 2 Wn Rn vector over sum of weight W1 plus W2 to Wn. This relation number 1. We suppose W1 equals M1G, also W2 M2G, and so on. Wn equals Mng. By substitution, where M1, M2, and Mn are mass of particle forming a raised body by substitution in equation 1. Therefore, dividing the numerator and denominator by G, we reduce that Rg position vector M1 R1 plus M2 R2 plus Mn Rn over M1 plus M2 plus Mn. The previous vector Rg relation can be written in terms of components in the direction of orthogonal coordinate axis OX axis and OY axis to get the following relation. Look at, my dear student, coordinates of component xg m1 x1 plus m2 x2 plus m1 xn over sum of mass m1 plus m2 to mn. Also, yg m1 y1 plus m2 y2 to mn yn over sum of mass m1 plus m2 to mn. Example, my dear student, we have two bodies, the mass of each 6 kg and 12 kg, and distance between them is 9 cm. Find the center of gravity of these two bodies with respect to the body 6 kg. My dear student, look at, we have two bodies. The first body 6 kg, its weight, act at origin point O. Second body is its mass 12 kg, act at point A. Distance between OA equal 9 cm. Look at, my dear student, let the line join the center of gravity of two bodies lies on x-axis, and the center of gravity of mass 6 kg lies at origin point O00. The center of gravity of the mass 12 lie on a point A 90, its coordinate 9 cm and 0. Then by substitution about xg, m1 x1 plus m2 x2 and mn to xn. By this method we have two bodies only. By substitution, then m1 x1 plus m2 x2 over m1 plus m2 equals 6 times 0 plus 12 times 90 over 6 times 6, 6 plus 12. Answer is 60 centimeter, and yg equals m1 y1 plus m2 y2 over m1 plus m2. By substitution about m1 y1, answer is 0. Then the center of gravity is point G, 60 and 0, its component. Center of gravity as a distance 60 centimeter from the first force is 6 kg. Then if we have, my dear student, two bodies, the first 6 kg, the second 12 kg, distance between them 9 centimeter, then the center of gravity as a distance 6 centimeter from the first mass 6 kg. Remarks, my dear student, the center of gravity of two particles where the distance between their center of gravity is constant L. We suppose, or we let the distance between their center of gravity is constant value L capital. This distance lies on the line segment joined between them and divided its length by inverse ratio to their mass. Now we are translate two important example. Look at, my dear student, ABC is triangle, AB 6 centimeter, BC 8 centimeter, CA equals 10 centimeter. DE are midpoint of AB and AC. Then 3 equal mass, each of them is M, are placed at B, D and E. Find the center of gravity of these masses. My dear student, look at CA squared equals 100 centimeter squared equal AB squared plus BC squared by Pythagoras theorem. Then CA equals square equals 100. Look at triangle ABC is right angle triangle at B. Why? Because AC square converse of theorem of Pythagoras theorem. AC square equal AB square plus BC square, then measure angle B is right angle 90 degrees. Let, my dear student, BX, BY are two orthogonal, and B is the origin point. Then what is the coordinate of point A? Excellent student, 0, 6. Point C as its coordinate 8, 0. Also D midpoint of AB is 0, 3. Y midpoint, we find sum of x coordinates over 2 and sum of y coordinate over 2. Its component 0, 3. Also by the method. By the same method, E midpoint of AC equals its coordinates 4, 3. It's better to form the following table to represent the mass and coordinate of each. Look at, my dear student, the table at B, at D, at E. What is the mass? At B, M, M, at D, M, at E. 3 equal mass. X coordinate of point B, 0, point D, 0, point E, 4. Y coordinate at B, 0, at D, 3, at E, 3. What is the origin point? Represent point B. Hence, the coordinates of the center of mass of the system, xg, by using m1 x1 plus m2 x2 plus m3 x3 over sum of 3 mass, xg equals what? 4 over 3 centimeter. By using yg coordinates, m1 y1 plus m2 y2 plus m3 y3 over sum of all mass m plus m, then yg equals 2 centimeter. It's a coordinate point center of gravity 4 over 3 and 2. This center of gravity of 3 mass. ABC is an equilateral triangle. Its side length is 12 centimeter. Mass of magnitude 3, 4, 5 gram are placed at its vertices A, B, C respectively. What you mean? Mass 3 at A, mass 4 at B, mass 5 at C. Determine the center of gravity of the system. Remember, we have equilateral triangle ABC. Look at, my dear student, we choose Bx and By are two orthogonal as shown in the figure. Consider B as origin point. Look at, my dear student, mass at A 3 gram, at B 4 gram, at C 5 gram. Side lengths of equilateral triangle 12. By using Pythagoras theorem or calorie of equilateral triangle, we can find the height from A is 6 root 3. Why? Because the perpendicular bisect BC, half BC equal 6 and AC equal 12. AC Pythagoras theorem 6 root 3. Point 0, 0, point B, point C 12, 0, but point A 6, 6 root 3, its coordinate. Then, hence the table for masses and their coordinates will be as the follow. Look at, my dear student, at point A, point B, point C, mass at A3, at B4, at C5. Coordinate X 6, at B0, at C12. Coordinates of Y at A6 6 root 3, at B0, at C0. By using the relation, the coordinate of the center of gravity of the system, xg equals m1 x1 plus m2 x2 plus m3 x3 over sum of 3 mass. Then xg equals 3 times 6, 4 times 0 plus 5 times 12 over sum of all mass. Then xg equals 78 over 12. xg equals 13 over 2 in simplest form, centimeter. Also, by using the same method, we find yg 3 times 6 root 3 plus 4 times 0 plus 5 times 0 over sum of all math equals 12 root 3 over 18 root 3 over 12 by simplest form 3 over 2 root 3 centimeter. Then the center of gravity of the system is g 13 over 2 x coordinate, y coordinate 3 over 2 root 3 with respect to the point B. Now we are translate to important example. ABCD is square, side length 10 centimeter, mass of magnitude 12,864 gram are fixed at its vertices A, B, C, D respectively, and mass 20 gram is fixed at midpoint of AB. Determine the center of gravity of the system. Let X, Y are two orthogonal axes of the shown in the figure, then form the table of mass and their coordinates. My dear student, look at ABCD square. We have masses 12 at A, 6 at C, 4 at D. Remember, side lengths of square 10 centimeter. We form the table A, B, C, D, and E. What is the mass? 12 at A, 8 at B, 6 at C, 4 at D, 20 at E. What is the X coordinate? At A 10, at B 10, at C 0, at D 0, at E 10. What is the Y coordinate? At A 10, at B 0, at C 0, at D 10, at E equals 5. By using the relation, hence the center of gravity of the system, xg equals m1x1 plus m2x2 plus m3x3 plus m4x4 plus m5x5 over sum of masses. Answer is 8 centimeter. Also by the same method we find y, yg, m1 y1, m2 y2 plus m3 y3 plus m4 y4 over sum of all math. Answer is 5.2 centimeter. Therefore, G, or the center of gravity, its coordinate 8, 5.2 respect to point C. Now, my dear student, we are translate to another example. Mass of magnitude 1, 2, 4, 5 gram are fixed at A, B, C, D respectively on Procol line A, B, C, D as shown in the opposite figure, where CD perpendicular AB and measure angle ABC 120, find the center of gravity of the system. Look at Procol line ABCD. Measure angle ABC equals 120. Measure angle CBD by using 180 minus 120 equals 60 degrees. Measure angle BCD equals 30 degrees, then BD equal half BC equals 6 centimeter. DC by using Pythagoras theorem equals 6 root 3 centimeter. Let AX, AY are two orthogonal direction as shown in the figure. Then form the table for math and their coordinates as follows. Look at AX, AY. AX, A is origin point, AB as a distance 6 centimeter. Look at the following table. Mass at A, B, C, D. What is the mass at A1, at B2, at C4, at D5? What is the X coordinate at A? 0, at B equals 0, at C equals 12, at D equals 12. What is the y coordinates? 0, 0, 6 root 3 and 0. Its coordinate of D. By using the relation xg equals 1 times 0 plus 2 times 6 plus 4 times 12 plus 5 times 12 over 1 plus 2 plus 4 plus 5. Answer is 10 centimeter. Its coordinate of x. Also yg 1 times 0 plus 2 times 0 plus 4 times 6 root 3 plus 5 times 0 over sum of all masses 1 plus 2 plus 4 plus 5. Answer is 2 root 3 centimeter y coordinates. Then the center of gravity 10 to root 3 respect to point A. My dear student, look at important remarks. If the string or rod has uniform density, then its weight is proportional to its length. My dear student, this remark is very important. If the string or rod has uniform density, then what you deduce? Its weight proportional to its length. Number 2, if a lamina has uniform density, then its weight is proportional to its area. Center of gravity of some simple raised bodies. My dear student, if we have uniform density rod, then the center of gravity lies at midpoint. The center of gravity of uniform density rod lies at its midpoint. The center of gravity of uniform density thin lamina in shape of a parallelogram or of each special cases, square, rectangle, rhombus, lies at the geometrical center or point of intersection of each diagonal. My dear student, this is very important remark. If we have lamina as shaped square, rectangle, rhombus or parallelogram, then the center of gravity, its geometric center. What is the geometric center of parallelogram at special case? Point of intersection of its diagonals. The center of gravity of uniform density lamina in triangular shape lies at point of concurrent of medians. My dear student, the center of gravity of uniform density lamina in triangular shape must be lies at point of concurrent of medians. Remember, the point of concurrent medians divided each median as ratio 2 to 1 from the vertex or 1 to 2 from the base. It's a point which divided median internally as 1 to 2 from the base. Number 4, the center of gravity, my dear student, of uniform density lamina in circular shape is the center of the circle. Number 5, the center of gravity of uniform density lamina in shape hexagon lies as the center of the hexagon. Remember, my dear student, if we have uniform lamina, fine lamina of mass 180 gram in shape equilateral triangle whose side length 6 centimeter, a body of mass 20 gram is fixed point D. Body of mass 20 gram is fixed at point D, and D belongs to AC line segment such as AD equal to centimeter. Determine the center of gravity of the system. Look at, my dear student, Let AX, AY to orthogonal direction where A is the origin point. Replace the mass of lamina which 180 gram by 3 equal mass each of them. 180 over 3 equals 60 gram. Fix each of the point at point of vertices of triangle, then the equivalent system will be 4 mass places. A, B, C, and D, where A is 0, 0, origin point, B 6 cosine 60, 6 sine 60, also equal 3, its coordinate 3, 3 root 3, but point C, its coordinate 6, 0, and point D 2, 0. Look at the following table. A, B, C, D, this vertices, and mass is 60, 60 at B, 60 at C, 20 at D. Remember, we divided 180 about A, B, C equally, then each mass is 60. X coordinate at A 0, at B 3, at C 6, at D 2. Y coordinates at A 0, at B 3 root 3, at C 0, at D 0. By using the relation, xg equals 60 times 0 plus 6 times 3 from the table plus 6 times 6 plus 20 times 2 over sum of all 4 mass equal 2.9. Yg equals 6 times 0 plus 6 times 3 root 3 plus 6 times 0 plus 20 times 0 over sum of all mass equals 9 root 3 over 10 centimeter. Then coordinates of the center of gravity G 2.9, 0.9 root 3 respect to point A. My dear student, by the end of the lesson, we know that any rigid body has a center of gravity, and there is line between the center of gravity of this rigid body and the center of the earth. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.